Okay, thank you to bearing with us to the bitter end. Not yet.
Not yet.
It is great that we have two talks in the beginning and the end of our conference being about parameters. The first one was the parameters are broken. The next one is parameterless, which is also very nice at the end of the conference. Please have a warm welcome for Allison Miller from all the way US Bank of America, more than 20 years. You cannot tell, experience in security, so I'm very interested in her talk. Give her a warm welcome.
Hello, everybody. I wanted to actually start off by giving you a thank you because I've seen how over the past few days you have been learning from each other and sharing stories about how to do what we do better. And I really appreciate that. As someone who's been thinking about the future of defense, application security is one of the places where we really need to make up some ground in how we are playing the game. So it's fun to be the closing keynote of an event like this because while you all have been learning about things that you can be putting into place now to be more effective at securing our perimeters, our infrastructure, our applications, we get to sort of end things on a little bit of a lighter note. So this won't be a technical talk. Unfortunately, there are no memes. I apologize in advance, and I apologize even further in advance because there's a little math. Just a little, though. Nothing that's going to leave a mark in any way. So I am also really excited to talk to you about what I've been thinking about related to the future of defense because of my relationship with AppSec. So AppSec and I go pretty far back in the sense that, you know, just like you, I am a digital native. I've been growing up with this technology, with apps and the web. I do remember a time before smartphones and IoT, but not very well. And I'm also a platform native in how I practice information security and defense. So my career, while it has started out in IT security, and I'm back at an enterprise working in IT security, I took a long, circuitous, interesting path through the woods to get back here. And I am one of those people who lives at layer 8. So last year, I was watching folks posting about all of the amazing contributions that they'd made to technology, and I thought, okay, well, I'm not sure the impact of my work, so I decided to sit down and count. And this was one of those times where I'm glad I, as the kids say, kept receipts, because I realized that over the course of a decade, I'd been protecting billions of things, but in a different way than most of my brothers and sisters in IT security. So I've been in some very weird corners of technology, places that you might not even necessarily consider to be security, but my role has always been around protecting things. I've worked in anti-fraud in payments industry. I've also worked in the game industry, going after griefers and gold farmers and cheaters. I mean, who even knew that was a job? So, and in fact, a lot of these things were not jobs till I got there. And so it's been really interesting, a lot of the lessons that I learned that I'm able to bring back into information security. And as we're talking about sort of the lessons that we've learned that we can share with each other, what's interesting about thinking about the future is how both you, working in application security, and me, working at layer 8, we're focused on the future, but our present is still kind of tied to the past. If you think about the OWASP top 10, there's a lot of perennial favorites, right? And then at layer 8, I'm still dealing with phishing. So some of these things, the more things change under the surface, the more interconnected and interdependency and complexity that we're introducing, the lines of code that we're responsible for wrapping our heads around and protecting, that keeps increasing, but our baseline ability to protect still seems to stay the same. So even though the state of the state isn't changing perhaps as fast as we'd like, the threats are evolving. And so we have to keep continually pointing ourselves and thinking about where the puck is going. So this is Europe, so where the football is going. And we have to kind of reconsider what kind of materials, what kind of tools that we can bring to bear to play this game, to solve these problems. And we've really done something interesting to ourselves because the world decided that those things that you and I have been set up and have careers around protecting, people, software, and secrets. The world has decided that those things which we used to be able to wrap around our protective arms around in a perimeter, those things are now on the outside. We've literally turned our model, our primary model, which is really, it's a castle and a moat kind of a model, the fortress model. We've turned it inside out. And so what we're going to need to do to be successful, to win, is to re-engineer the stack all the way from the hardware through the software, all the way up to the wetware. And in order to do that, we really need to take a look at this model that we've been using and figure out what other models now we need to use. Because we will hit what we aim at. We will solve the problems that we focus on solving. And so how we frame that problem and the models that we bring to bear to help us in figuring out how to solve those problems are really important. Okay, so now we're going to do something completely different. I'm going to tell you one of my favorite stories for thinking, a model for thinking about defense. And it's a story that I think most of you are familiar with. It's David and Goliath. So way back when, there was a great battle, two armies at a standstill in a canyon. It was hot, kind of like it's in here. And what happened is one army decided they would send out their champion, Goliath. Big guy, huge, powerful, like hams for biceps, that kind of guy. 17 feet tall, and he came out, and he stood in the circle, and the armies decided, okay, the other army can send a challenger, and whoever wins this battle wins the fight. And you guys know what happened next. The other army sent out David. Little guy volunteered, I'll do it, I'll do it. Was just a sheep herder or something like that. But he had a slingshot, and he was smart, and he was fast, and he set himself up to go against this amazing champion. So all of you amongst you, I think you know the story. Who do you want to be in that situation? Well, some of you sort of murmuring Goliath, but you know what happens next, right? David comes down, whips that slingshot around. Goliath takes one between the eyes, he's out like a light. And the thing is that I think it's human nature out of that story. We all want to be David. We want to be the underdog. We root for the underdog. And as security folk, we're all at our root hackers. And hackers make the world based on how nimble they are, how fast they are, how quick they are, how smart they are, how independent they are. And so we frame this story and we think, okay, if hackers are David, oh my gosh, isn't Goliath a perfect metaphor for an enterprise or for a company? Big, powerful, but slow, just kind of sitting there, not necessarily ready for what's coming at him from David. Yes, I think most of us think of ourselves, when we're practicing defense in an enterprise, we're stuck as Goliath. We're slow. We have a lot of work to do. There's no way we could keep up with the David. But as we're thinking about how this story is framed out, there's another thing that you should know about this fable, this parable, is that historians think that it really happened. And moreover, they think that Goliath was actually not just big and powerful and the super champion that we painted him to be in order to make David such a great underdog. He was actually old and sick and partially blind. Yeah, exactly. So who is the real underdog? Well, there's another piece that lets you know who the real underdog was, which is the way that battles worked then is that one army would send a champion, and yes, sometimes when you're at a standstill, the other army would send a champion, but they usually sent like to like. And there were three different companies within a typical army. One is the Goliaths, right? The foot soldiers, they were big, brawny, they carried swords and shields, and they kind of lumbered along, and they were able to, do man-to-man combat very effectively. The second type was the David. And they were essentially ballistics, right? Those slingshots got very quick, and essentially David was a sniper. He was able to work at a distance, he had great aim, and the thing is that the sniper always wins against the foot soldier. So in addition to being an information security nerd, I'm also an economics nerd, so I like myself some game theory. Any of you heard of rock, paper, scissors? Yeah, so rock, paper, scissors is a great simultaneous game because, you know, Rochambeau, and you both have to go at the same time. Why? Well, because if it was a sequential game, it wouldn't be a very good game at all. Rock, paper, right? Which is essentially what happened. So this was a battle where normally like would call to like, and they would send out a champion like Goliath to fight him, but instead, one army sent out a rock, the other army thought about it a second and sent out paper. But there's kind of good news for us if we want to learn from this parable, fellow Goliaths and Davids out there, which is that there was actually a third part of the army, and that was the cavalry. So these are folks who were on horseback, they were fast, they were powerful, and they were extremely agile. So in so much as Goliath was a rock, David was paper, the cavalry was scissors. So they were able to, the Goliath actually would have been able to take out the cavalry perhaps, but the cavalry was able to get away. The horsemen were able to get away from the snipers because they were able to change direction so quickly. So I really like this as a story because it starts to point us in a direction of what we might need to do if we're going to re-engineer the stack of defensible systems from the ground up, which is that we maybe instead of being Goliath going forward, maybe we can't be rock anymore, we need to be scissors. And always bring duct tape because any engineer worth their salt is going to have duct tape. And if you've worked on any of the systems that I've worked on, you know duct tape comes in handy sometimes, and with baling wire. So that's okay. That's ancient history. What really does that have to do with us? Besides the lesson of agility, agile DevOps out there, I think that that's a leading indicator, as we say in economics. Okay, so again, how did we get here? So the way that we got here, where we are today, is that we started off with a pretty simple model of defense, which is that all of the stuff on the inside was the good stuff that we were protecting, and we wrapped a boundary around it, and our job was keeping the good stuff on the inside and keeping the bad stuff on the outside. And how well did that work for us? Well, it stopped working at all, basically, when we started having businesses that depended on this technology because businesses realized that they needed to interconnect with each other. So we suddenly had, in addition to a very porous boundary layer, we had a lot of interconnections between suppliers and customers, and there's this cloud cumulus form that a lot of us are connected into one way or the other, whether or not we're doing cloud computing. A lot of us are in some way connected to the web, so a network of everybody else's computers. And the services that the businesses that employ us are providing involve customers coming in. We're service providers. In order to provide the service, things on the outside, the scary, scary outside of the boundary, have to get on the inside. And here's where the stuff got interesting for me at layer 8, which is that any organization that I've ever worked with has had a threat vector that is very relevant to the service that it's providing. So if you are providing payments, you're going to have credit card fraud or some kind of payment fraud or scammers of some kind. If you're delivering messages, there will be spam. If you are, let's say you have a login process, you're going to have folks attacking the login process. Could be bots, could be something else. That, not to say anything of all of the bots and malware and everything else that's coming your way. So immediately then, along with the good folks who are coming into your system, there's going to be folks with ill intent coming into your system. And that doesn't necessarily mean that your application code has a problem. Your application code, when you're processing a credit card payment, if the credit card payment is properly processed, the code works fine. The problem is the folks' intent and how that business process can be exploited. So then what the game became, at least for the folks at level 8, is differentiating intent of a valid process. Your service is processing potentially millions or even billions of events per day, and someone somewhere at your organization might be responsible for differentiating good from bad. And if it's a scaled enterprise or scaled service, they might be needing to do that in real time. So that's how we got here. And here are some of the models that I've found to be useful to me at layer 8 that I suspect are going to be useful up and down the stack. I just want to share with you real quick. So see, it's easy. It's the closing address. It's just really light today. So the 3 types of models I want to go over are threat models, which we talked a little bit about today. I heard someone talking about threat models today, and I loved it. Choice models, just a little bit more product-y. And then behavioral or analytic models. That's where the math is. I promise I'm going to keep it a light touch. So with these new models, we start to play new games. So threat modeling is essentially the game of what if, what could happen, what bad thing could happen. It's looking at your environment, your business, and figuring out what weird stuff is going to come at me. And here's a pretty simple threat model. If anyone recognizes this kind of diagram, Schneier wrote a paper on it in 98, 99, attack tree modeling. So obviously that's filled in with a Rickroll, and a little bit of Blondie, but what you could have in there are different types of threats or attacks and how then they might chain. I like these diagrams because they're easy to read. It gives you kind of a sense of the story of what you're working with. The other thing why this is useful, and another reason why it might look familiar to you, is because there is a variant of this that is how we all learned about probability when we were about 11 or 12 years old, which is that different things could have different probabilities associated with them, and then chaining them gets you to some sort of ultimate probability, which is how I first stumbled across this kind of diagram because I was a risk nerd. And so I was really interested in quantifying risk and understanding the likelihood of different types of outcomes. And so this is how I started with threat modeling. But I also worked embedded in a product because I was at layer 8 and trying to make sure that not just our codes and system and network were resistant to attack, but our products were resistant to attack. So I started working with a different kind of a threat modeling variant, which I call an attack and defend model. So what you see up here, and I'm sorry that the connective line is a little bit faint, but this is how I think of a product flow, how a user on your system, a consumer or a business, depending on what kind of application you're running, how they might do something that your business is trying to get them to do. So this is essentially a light version of a checkout flow. I think you've all been through a checkout flow. A product manager somewhere put up wireframes to get you through a checkout flow. And the checkout flow is, ooh, you have a cart full of awesome stuff that you want to buy. And so then you need to log in or check out as a guest. If you log in, maybe you have payment details on file. Maybe you're going to use that. Maybe you need to add a new address. Maybe you don't because it's a digital download. Or if you are checking out via a guest flow, then you need to put in payment details, right? I mean, roughly in your head, you've been through this at least 1,000 times in your life so far. You probably can kind of guess how this works. So that's a basic flow. And then the attack defend piece of it is you think, oh, payment flow, what could go wrong? Quick, let's threat model it and let's figure out what kinds of things might go wrong and then where the flow would be subverted by someone with bad intent. So if it's a checkout flow, what can you do? You could log in with someone else's account, with someone else's credentials, right? They have payment details on file. As soon as you get in, score. If you don't have someone's account details, maybe you're going to put in a stolen financial instrument. There's all kinds of different things that you could do. And if you're not sure, you can just have bots try, right? So there's different places where you might realize that an attack could be happening, and then you can put in a defense. You either put it in right where the attack is happening or someplace after so that you can stop the bad thing from happening. Okay, so this is the first. It's a threat model variant that works at layer 8. So the next game we're going to play, the next model I want to tell you a little bit about is choice models, which is the game of what will. So, and this is essentially where we say, okay, we know that there are bad things that could happen, but most of the time, someone's going to be using the system with good intent, and we want them to actually be able to enjoy the service that we provide at some level. So this is about, choice models is about trying to help the good folks get through the flow, right? And an example here, basically this is designing your product in a thoughtful way so that the default is a good outcome. This is some serious jujitsu. Like, this is pretty advanced level product design. But an example that I'll give is one that comes from designing malware warnings in browser flows. So, and the concept here is opinionated design. The average user might not understand what you're trying to tell them if you know that they're downloading malware, but you as the browser may have a better sense of whether or not it's malware than the user, and how can you help them default to the good option? Understanding, of course, that there's going to be power users like you all who want to download the malware anyway, retaining the choice, but making it really super easy for an innocent user to avoid harm, okay? So you see the first warning there was not opinionated. It was the message, it was clearly written by an engineer, and they wrote, it appears malicious, keep discard. So an average user might say, it appears malicious. It doesn't say it is malicious, just says it kind of looks weird. Okay, keep discard. I don't know what either of those buttons are going to do. And they look exactly the same, so 50-50, I'm going to click one or the other. Anyway, 72% of folks got through that safely, which was discard, was what you were supposed to do. But there's really no way that you would know that. So redesigning that flow to make it a little more obvious that the browser thinks it's bad, you see the warning label, it's malicious and Chrome has blocked it, so defaulting to keeping someone safe, and then recover malicious file if you're a power user such as yourself, or just simply remove. So that got 93% adherence, which meant that 93 folks who went through that flow, they opted for the safe route. And so this is really useful because if you are responsible for protecting a system, and you deal with product managers or business people, when they think about something like a payment flow, they think about what they call the happy path. They design for the happy path. You're at a retail site. What's the happy path? You bought something. That's what makes the product manager really happy. And if you can inform them of these places where there's going to be a user is going to make a choice that could lead them or the system into harm, they can put happy paths on those too. They can introduce these security controls that you know make your system better, but they can actually have informed design there too, as opposed to what I have experienced somewhere in my storied past, where when a user was declined, their credit card was declined, they got a big red error that said suspected fraud, code 007, which is not a happy path for a user. It also doesn't give them any idea what's going on or how they can fix it, so they might try over and over and over again to get through a flow, which, by the way, just jams them up for like 3 days straight. Okay, so that's another kind of model. Choice architecture is how you might hear it described in behavioral economics. And then the last model, the last set of models, this is my bread and butter. So I've worked with, oh, okay, yeah, there's a mic there. I've worked with these other different types of models within design, but analytics is where it gets really real. Like really real, like real time real, like affecting user experience real. And these types of models, which is where the math comes in, tend to be most useful when the attack pattern is complicated enough that many variables might need to be taken in consideration at once, and that it's faster and easier and cheaper for a machine to do it than it would be for a human to do it. And it's dangerous enough you would like something to happen in real time rather than waiting to figure out something has happened after the fact. And so this is the game of what is. What is happening right now? This event that is transpiring, do we think it's good or bad? And this is where we get to this advanced level move, where we try and design our systems so that they can protect themselves, so that in real time, we are rejecting things that are harmful from coming into the system. So I feel like I'm having a little trouble reading the room, but I'm guessing that there are at least 5 of you who are gripping your seats saying, oh no, she's gonna talk about machine learning or artificial intelligence, and I am, but I'll probably focus more on what it used to be called, which is statistics, and I will let you know that it is not romantic or exotic in any way, because the basis of it is what a lot of us learned in maths or in sciences around hypothesis testing. So these types of models are essentially from science. They're from actual science. They're data science now, but it used to just be that, hey, this is the way that you did experiments, and you were able to come out with algorithms that helped you understand the probability of different things happening. So it's been used in operations management, in insurance, and in marketing for a very long time. And within security, there has been a lot of work in this space in fraud detection, spam, malware scans, although I know feelings about using machine learning in malware identification, and intrusion detection with varying levels of success. And because it's not magic, I'm just going to break it down for you, because the model build process is, it's not rocket science. It's actually something that happens in a lot of different places, and it's not magic, but it's really good to understand how it works, because a lot of you may be given the opportunity to purchase products that leverage these techniques, and it's useful to understand how you might build your own so that you can understand what use you might be getting from some of these tools that might be pointed at you. So basically, it's a cycle. Risk detection systems work as part of a learning system. And the steps are, you figure out what bad is, which, by the way, is the #1 step that people miss, which is pretty bad, because that's the first thing that, it's what everything else is based on. Clarify what's bad. Find useful signals, meaning useful things in the data that would help you understand if something is good or bad. And then the model build process takes like 15 seconds, because modern computing is awesome. And then you have an algorithm with which you can work with your business folks to tune the trade-offs so that they are happy, and they can help you define a happy path for wherever this is going to go in. And then you build it into enforcement systems. That's the fun automation piece. So starting with clarifying the bad definition. All right, so essentially what this involves is wherever the bad is that you're looking for, getting a very broad sample and actually coding every single event that you can find as being good or bad. So in the fraud world, this actually means looking at payment transactions that have either happened or not happened, that have happened and turned out to be fraud, or happened and turned out to be not fraud, and coding them. So the reason why most people don't do this is in an enterprise context is because it's very hard to know what good was. And because if you look at an incident, being able to chain together all of the events, like from the very root all the way through, and then get a generous sample of good stuff, it's actually really hard. But that is the key. It can't just be signatures, it has to be actuals. because you want your model to be as crisp as possible, as accurate as possible. And the only way to get it to be accurate is to train off of both bad and good. So funny story, it wasn't very funny for me at the time, but funny story is that we had a model that basically ate its own tail in the sense that it was training off of its own output. It was really good at finding things that were bad for a little while, and then it thought everything was bad because it was training off of its own data exhaust. And so you want to make sure that maybe you even oversample your good stuff, just so that you can have a model that isn't psycho, which can happen sometimes. Okay, so the next thing you do, and this is my favorite part, is that you find useful signals. And so this is my favorite part because there's essentially a storytelling that happens, which is, I've worked in fraud for a long time. I know almost everybody has a fun fraud story they want to tell me, and they want to hear my fun fraud stories because I have a lot of them. But essentially, there's a story here. Like there's a plot. Any given transaction, there could be a plot. Okay, so let's say you have a transaction. A user is logged in from one country, but their billing address is in a totally different country, not just a different region, not just a different postcode, it's in a different country. And what are they buying? They're buying prepaid mobile phones. And they're gonna even send them to a third country. Okay, that looks totally sketchy, right? So the thing, and maybe it is, or maybe you actually have historical transactions that show you that this person actually resells prepaid mobile phones. Like that's what they do, that's their business. And so they actually do transactions like this every day. Is that me? Okay. They do transactions like this every day, in which case this is probably a low-risk transaction. But in order to get the details of that story in a place that can be evaluated, you need to extract out the data from your records. So I differentiate only slightly between records and logs because in an application, something like a payment transaction might actually be a record versus something unstructured that's coming out of your servers that might be considered logs. The differentiation is really just the emphasis you put on the different syllable. The point is that it's data, but in order to figure out that someone is logged in from one country and their billing address is in another country, someone needs to realize that both those country codes represent country and somewhere have a variable that says those things match or those things don't match or those things are there has to be additional variable creation. So most of us are dealing with systems where the logs are like really long, and in some of these systems where you are gathering descriptive variables and you're figuring out what's going to feed your model best, you end up making your data very wide as well. And that is how you can extract useful signals out of ground truth. And there's all kinds of magic we can do about that, and that's my favorite part. But then we get to what all of my interns' favorite part has ever been, which is that they want to do machine learning and they want to do data science. And so they want to train a model. They want to build that model. And I explained to them, all right, we'll build a model, but you understand 99% of your work is going to be around prepping the data and making sure that it's clean, and then doing the variable creation, which is the fun part for most people's consideration. And then you are going to write maybe a line of code, and you're going to hit enter, and then the machine is going to do the rest. So that my favorite algorithm is a logistic regression. That's still what's used in a lot of fraud shops, although they are moving into more unstructured, unsupervised learning type things. And this is the only code that I will be showing today, but this is essentially what building a model technically would look like in something like R, which or Stata or SAS, which folks who maybe still describe them as statisticians might use, versus something like newfangled like TensorFlow, which by the way still does linear classifiers, yay, in addition to all of the other magical machine learning that it does. And that's the code, and you click enter, and then you have a model. You have some kind of algorithm. And one of the reasons why I like the statistical variance, just so you know, is because the output of them, you can almost read it. And so you can actually figure out what behaviors or what variables, how risky the weight that you would give them. And there's a lot of other fun stuff around segmentation and great model fun. But the point is that you have some kind of algorithm, you have some kind of decisioning capability, and then you can tune it, because your model's always going to be wrong sometimes, and sometimes it's going to be false negatives, and sometimes it's going to be false positives, and which one do you care about more, and which one does your business care about more? And that's very important, because in some businesses, they have such great margins, they can bleed fraud. They don't really care. But one person gets declined, oh, it's painful. So being able to understand the appetite there is really important. And it's one of the things that I really love about risk models and working in these real-time detection technologies, because you can actually see the performance and you can talk about it and you can quantify it, and that's really useful. So I'm going to just give you a quick explanation of how we can talk about model performance, which is, so I've created this fun axis. So let's pretend that the vertical axis, percent of bad equals true, is, you know, what portion of what you have made a decision about is fraudulent, and then there's percent of total, meaning like all transactions. So if you kind of imagine that, let's say we have some portion. This will be total payment volume, and that will be the portion that was fraud. So if we were randomly picking, that's the straight line, randomly picking. And so what that would mean is that you would have to decline, let's say, 50% of all transactions in order to get 50% of the fraud. Since fraud's probably like 4% or less attempts, I mean, not actual losses. But since fraud is really low, you would really not want to decline 50% of all of your transactions in order to get just 50% of the fraud. Of course, if that's how you were doing your authorization strategy, your fraud would probably be higher, maybe it would be more useful. So what you actually want is you want to do better than random, right? Everybody up for doing better than random? And so that's where you want to see curvature. And ideally what you want to see is you want it to be as steep as possible, because really you'd like to be able to decline 100% of fraud and none of the rest of it. That's the ideal. That would be like straight up and over. We don't often get there because decisioning technology is not perfect and adversaries learn. We'll get to that in a second. Anyway, that distance between random and how your model is doing is called gain. And you always want to live on your own horizon. That's the most efficient place to be. You want as few false positives and false negatives as possible. You don't want to have to decline 80% of your total transactions to get 20% of the fraud if you don't have to. So you always live on your horizon. It's sort of similar to some financial modeling that you would see, where they talk about the efficient horizons and that curve. And so what you want to do, though, is while you always want to live on the curve, you're stuck with it. You're stuck with that trade-off unless you have a more powerful decisioning technology. And that, by the way, is how you get investment. If you can tell your business, listen, we're only able to take this much data into consideration, we only have this much compute, if we get this much money and funding from you, we can actually invest in the technology and improve it and improve performance. They love that. That's life at layer 8, friends. And then what you do is you build it into enforcement systems. And that usually looks something like this, where the top level will be what a user experience is. We were using a payment flow before, but it doesn't have to be. It could also be their inbox. It could be the points in their gaming account, whatever. There's some event that happens, an event of interest to you, an event of interest to the product, because it's a place where something could go wrong, something bad could happen, and you want the platform to have a chance to make a decision about it. And then the user experience changes. So someone asked a question yesterday in one of the talks that I was in that was about whether you could build these things, whether you had to build these things yourself, whether they really happen, or whether you could use third parties to do this. I've only ever seen it work native into the platform, but the idea is that based on whatever decision you make, it can change the user experience. Because an approval is different than a decline. If something has been labeled spam, that's different than if it has not been labeled spam. And so you have a post-decision UX. And then, here's the magic of this. Is Tanya still here? Because she talked about feedback loops. And this is where the magic happens, is that after the transaction, after you've had whatever event has happened, you then have that data, and it's a loop. The problem with this type of automation is that it's forever. You can never stop learning. On the other hand, why would you want to? Because you can make it better and faster and more performant over time. And then the models of which we speak. A lot of folks get really focused on the sort of magic machine learning, but it could be anything. It could be velocity rules. It could be whitelists and blacklists. It could be heuristics that you've come up with due to experience. The point is that you have it available in time to make some kind of decision that affects the outcome of the event. And for me, the magic, again, is the fact that this is a learning system. And when you have systems that can learn, you have a chance to improve performance. And again, this isn't rocket science. It's been used in a lot of different places within information security and outside of information security. And from my experience, this type of approach is being used in more and more places. So, as promised, I showed you a couple of different types of models, both from the more theoretical designy threat model all the way through to something that would be implemented in real time. And the reason why, again, is because when we frame problems that we're trying to solve, the way that we frame them, the model that we use for ourselves, it changes the solution set that we consider. It changes the options we give ourselves in architecture. And if what we need to do as an industry is to build more defensible systems, build defenses into our systems, then we need to consider many different types of models, because we need to have more design tools, and we need to get more embedded into these systems. Because I will tell you, at layer 8, I was completely dependent on layer 7 and below. I could only focus on layer 8 because that's where I was living, but I owe a lot to all of my friends and colleagues who were working at the application level and below. And so, quick takeaways is that the game has changed. We all know the game is changing, even though some of the pieces on the chessboard or checkerboard, depending on which game you're playing, remain the same. The game is changing, and so too we must change as well. And I think that we all have kind of a handle on what game we're playing and who the players are and roughly where we are on the board. But then to learn from every move and continue to invent new moves. And then the lesson of the scissors, again, the folks who are on the scissors, not Goliath, not David, but the cavalry, is a place where we as defenders might want to go, because they use their strength and power to, in pair with agility, to have momentum, to be less predictable, and therefore that seems like a stronger point if we're playing against paper Davids. In any case, I am really excited to be so closely connected to the AppSec world as I continue to work on level 8 problems all the way back down the stack, and I hope that we can learn and invent new moves together. Thank you very much. One more frame. Cool.
Thanks a lot. You want to take one or two questions?
I will take questions.
Any questions? Please come forward.
Thank you, Selena. I'll just make a suggestion that you consider the use of the term normality indicators for those good things that you're looking at, which is a
Okay.
recognised term in other parts of the industry. I'll take that offline with you after.
Okay. Normality indicators.
I think the folks are getting tired. Oh,
Yes,
here,
I know. I'm between you and drinks.
And the closing.
One of the things that you've concentrated on there is actually the external client interaction. But what about partners acting as bad faith actors? Have you got anything happening there?
That is a good question. So I think you all heard the question. It was about partners. Well, I guess what I would say is, yes, for the problems that I've been focused on essentially customers and the problems that we face in a product. But I think the model works anywhere where you think that there is a decision point. And I would agree that any place where there is a connection from the outside to the inside, even inside to inside in a lot of our environments, I think that we might want to put our eyes there. And to, I also think that those types of things should be threat modeled. In most of the environments that I'm working in, a partner connection would certainly be threat modeled. APIs, certainly we're going to have a threat model. And then if there are real-time decisioning implications and we are able to differentiate good from bad on the fly in that way, then the analytical models might come into play. But I absolutely, there's always risks in the in-between places, aren't there? Any other questions? I think I see one in the back.
Yeah, all the way back.
Whoa. Come into the light.
Step into the light. Yeah.
Hi, I was wondering if you know of any efforts. The OWASP has lots of cheat sheets and lots of checklists to deal with various information security risks in applications, and we can basically just look at the wiki and check that we ticked it all. But do you know of any projects or efforts that are doing this for like the what you call the layer 8 risks? Like if you ship something, this is what people will try to do with you. If you deal with money, this is what people will try to do with you. Because you see startups and they try to reinvent the wheel, and so I wonder.
Yeah.
And if is there maybe something that might also be interesting for the OWASP project to?
Yeah, I agree that it might be interesting as part of my complicated relationship with OWASP is what are the right forums, what are the right tools for the layer 8 stuff, because it is connected to everything else underneath. The answer is, I don't know. A lot of that expertise is tied up in people's heads who've been working in that. And do I have any threat intel friends in the room? Although sharing practices among defenders is definitely like a rising tide lifts all boats, there are a few places where folks they're not yet conditioned to really share. Sometimes they think it's their special sauce. Sometimes they feel like there's some sort of advantage, or they're very, very afraid of leaking the decisioning points, right? Because if the whole world knows that you're going to decline if someone tries something 10 times within 3 minutes from the same IP address, then they can kind of, try 9 times and then do something else to evade. So when you're dealing with adversaries, sharing those types of models, it gets interesting. I think that there is definitely an opportunity to do more sharing in that space. Maybe I'll write a book, or maybe start a project with OWASP. I think there's definitely possibilities there. I will say, as kind of a rough rule from my experience, when you're working in these types of systems, things that are new tend to be riskier. Like the first time something's been tried, the first event being attempted from a new connection or a new customer account, those tend to be where the risk concentrates. The other thing is that although I've seen lots of attempts to aggregate data across entities, every system that I've been in, the models trained based on local experience outperformed ones using borrowed data, which is a little, but we'll get there. Any other questions? I think time-wise, we are done, and they need to pack up. So thank you so much.
Thank you.